In our last video, we saw how we can divide into a polynomial and reduce the number of factors that we have. So given where a particular root is on the graph, like we've been practicing here, we've been looking at this graph and focusing on this root, the value of 2, x equals 2. And what we've been practicing is deleting that or dividing that out of this factored form. So effectively taking the graph that's in green of standard form and reducing that factor by a power of 1 and changing the way this graph looks. So like we can see here from the visual, the graph has changed. The red graph and the green graph no longer overlap. And if we go in and edit this again, to get a little bit better view of what that looks like, let's say we go down just a little bit. And we go to up just a little bit higher. Just trying to get a better view of the the way this picture should look, so that we can see all these key features here. All the turns and twists and things like that that happen. Just because this graph here is quite large, and we're missing a lot of features if we stay too zoomed in. So I just did some editing there to be able to see everything, and like we can see here from these graphs, the red graph is what happens when we reduce or divide out one of the x minus 2 factors. And the green graph is the original graph. So like we can see here, that multiplicity of 1 and green, it's slicing through. When we divide out one of these factors, 2, that multiplicity in red stays the same. That's still just slicing through that graph. It's not bouncing off and it's not swerving there. In fact, we can zoom in to be able to verify that. That red line, right, well, that still appears to be linear, right? Just like the green one appears to be linear when we zoom in that scenario. Now, looking at the 0 here, the root here, what we wanted to see in green is the bouncing off, right? The green line there is turning and hitting like it's bouncing off of this x-axis and then going down again, right? It's not cutting through. Down here, it's negative values for y. It does not become positive at the other side of 2. So when x is greater than 2, this does not become positive. This stays negative values down here for these y values. And what that means is that when we look at the red graph, since the red graph goes from positive values to negative values, it's cutting through, which means we're seeing a different multiplicity now that's depicted by us dividing out one of the factors. So here we can see a little bit better. Green is bouncing off, where red is slicing through like a straight line. And then the final multiplicity there that we had that we could see in the factored form, not dividing out one of these x minus 7 factors, we still see the green line swerving and hitting this point, this root, and then becoming positive on the other side. So quite distinct difference between the swerve here and the straight line slicing through that we saw over here in red, right? Not a swerve, just a line, a cut viewpoint when we zoom in enough. And what we want to see is just a little bit better way to deal with division. So one of the things we saw last time was how to do long division. And what we're going to learn how to do this time is just a synthetic version of that. And a lot of people end up preferring this synthetic version just because it's a little bit less writing and you don't have to deal with the terms and the variables at all. So what we are going to do is we're going to take the root of the factor that we wanted to divide by. Our divisor was x minus 2, which meant the root there, the solution there, was x equals 2. And what we're going to do is divide by that root. Usually we will, set up the structure here kind of like this. We'll draw this little semi box around the value of 2. And then what we're going to do is copy down all of the coefficients on this standard form. So we're always going to begin with the highest order exponent there. So we'll write a 1, and because the 22 is negative, this term will include its sign, negative 22, positive 160, negative 310, negative 1085, 4,508, and negative 4,116. And what we're going to do is draw a large line here. This large line is going to be basically our addition line. And, just like how we would add two numbers like this, that's what that bar is going to represent there. And what we're going to do is instantly drop down the first number. So this first number here, this lead coefficient's value is always going to drop straight down in our synthetic division here. And what we're going to do is go through a zigzagging process of multiplying and adding. So 2 steps, we will put the multiplication in green here. And I guess we can put the addition in blue, right? So we're going to zigzag like this. And so the first one here stays in red because, again, we drop down that lead coefficient of 1. So that always will be what this value is. And the next thing that we're going to do after this is multiply the divisor 2 by this dropped down number. 2 times 1 is 2. And what we're going to do is take that 2 and write it here. So we multiplied to get this. And then we're going to add straight down negative 22 plus 2 to get negative 20. So we added to get that. So we're multiplying to get green and then adding to get blue. And the next part there is going to be, again, a multiplication. So we're going to take 2 times, this time, negative 20. And a lot of the times when we see this drawn out by a teacher, we will see this is what I mean by the zigzag here. We will add straight down, and then people will see the multiplication coming back up this way, right? So we're again doing 2 times negative 20 is negative 40 to get this part. And so this will kind of zigzag us back and forth like this. So let me use this kind of yellow here. We'll go down, and then we'll go up, and we'll go down, and we'll go up. And every time we change directions here, we're going to be doing a different operation, just alternating between multiplying and adding. And the convenient part about this is that we're always going to be multiplying by the same number. We're always going to take this factor of 2. We're always going to take this number times our blue number down here at the bottom. So those two things are really what this is all about as far as the multiplication goes. And the adding part will always happen straight down. So between these two values, whatever these end up being, right, we get the green by multiplying first 2 times here. That tells us what this number is. And then we just add straight down to get what we multiply by next. So we're still multiplying by the same thing, always times 2 in this problem, because that was the solution, the root to that factor. All right, that was the 0 there. So that's where that comes from again. And then we're going to kind of continue this process. So we're here, and we're going to do 40 plus, 160 plus negative 40, or 160 minus 40, which is 120. And then we're going to multiply again by 2 times 120 is 240. I want that in blue there. So 240. And then we're going to add straight down, which ended up giving us negative 70. Oops, got my colors switched up there. Want this in green. And I want that positive. All right, and then we got down here in blue, we're going to have 70, negative 70 here from 310 plus 240, negative 310 plus 240. And then another multiplication. So back up here, 2 times negative 70 is negative 140. And then we're going to add straight down. It's going to be a 5 and a 12. Carry the 1. 1 plus 1 is 2. Get a 2 there. 1,000 stays the same. And that's a negative because both of these are negative. Then 2 times 1,225. We go here in green. So that's going to be 2,450. And it's going to be negative because this was negative. Again, add straight down. And an 8, 5, 9. Whoops, that's negative. So still 8, still 5, and a 1 there, and then a 2 here. All right. And it's going to be a positive answer, and then we're going to do that times 2 again, which is going to end up giving us exactly what we wanted here in green. And what we wanted there to happen is to get 4,116. And then when we add this final time, we'll want to notice that we get 0 there. All right, so let's put that in orange. All right. Now this 0 is a good thing. It means that the remainder to the division is 0. And if you remember anything about division, that means that it goes in evenly. And what that means is that our divisor, right, dividing by a root of x equals 2, which was a factor of, right, so basically if we divided by x minus 2, it went in evenly, like we saw originally in our problem. And what that means is that x minus 2 was a factor of our original polynomial. So getting this remainder of 0 there, that's what that means, is that was a place on the x-axis where this graph originally crossed, and what we just did was get rid of it. We divided it out. So if you get anything left there in that position, then we have a remainder, and we have to write that specifically. So before we get into that, let's just talk about how to take all these numbers and make sense of them. What we want to be able to do is take these and put the coefficient or the variables on each of these like these are coefficients. So what we'll want to notice, that's stuff on here, is that this exponent is to the 6th power. And like we saw before, that if we divide out one of the roots, especially in this factored form, when we look at this factored form, this originally had an x minus 2 squared term. And so if we divide one of those out, that's going to decrease that exponent from being a 2 to being a 1. And what that's going to do is that's going to change the entire order of this polynomial. It's going to change it from being a 6th degree to a 5th degree. All right, it's going to decrease the amount of times that it crosses the x-axis by 1 because x minus 2 was a factor since we got 0 from the division as a remainder, right? So the way that we take all this information in Just understand that that biggest exponent, anytime we divide a factor, whether it goes in or not, doesn't really matter there, is that that biggest exponent is always going to decrease by 1. That exponent's going to decrease by 1. So is that one, and that one, and that one, and that one. Right? They're all going to go down by 1. So the nice, easy way to take all this is to just take these numbers at the end and write 1x to the 5th, because it's going to be 1 less, minus 20, like a coefficient, x to the minus 1 from the next biggest exponent, so x to the 4th. And because these exponents up here go completely in order as 6, 5, 4, 3, 2, 1, 0, these will all follow suit. So this will be plus 120 x to the 3rd minus 70 x squared minus 1225 x. And then this will be our constant term, so just plus 2158. And because the remainder was 0, there's nothing after this. This is just the new equation that is graphed here in red in this picture. Right? So the graph in red there is basically what we're looking at when we decrease. So we have the same order of root here, but this order changed because the red graph, like you can see at that section, is not bouncing off anymore. It's cutting straight through, whereas the green graph is bouncing off at that spot and going back down. It doesn't go above the x-axis on one side. And there you have it. That's synthetic division.